So how does this happen in stars? Before we understand how it happens on Earth, we have to know how nature's doing it on its own so easily.
Yeah.
And I'll tell you, it's not at all how we're going to do it on Earth. But the sun's core of the sun, has about 150,000 kilograms per meter cubed of pressure. That's about 150 kilograms per decimeter cubed. A decimeter is a 100th of a meter. Just imagine that.
That's difficult to imagine.
Can you every 100th of a meter? Imagine on your if you and I were in the center of the sun.
Oh,
yeah, we would have every decimeter, every 100th of a meter, 150 kilograms of pressure on us. Every decimeter of our body.
Yeah.
Or if you want to say every meter, a meter is about 3-ish feet. So you and I are, roughly speaking, 2 meters tall. You and I would have 300,000 kilograms pressing against us on all sides. 300,000 kilos.
Jeez. That's a lot.
So if you and I were in the center of the sun, we would immediately get crumpled up into a tiny, tiny, tiny little ball.
Yeah.
Because if you try to imagine bench pressing, even something like 100 kilos, which is heavy as frick for me. What is that, like a couple hundred pounds?
Yeah.
100 kilos is not even the weight that would be on 1/100th of a meter on your body. So it's just like the center of the sun smashes things together so profoundly, it's insane. That is something that we can't do here on Earth. We don't have that kind of pressure. Because of all that pressure, it's about 15 million degrees Celsius in the center of the sun. 15 million degrees Celsius. That is more than hot enough to strip away any electrons from the nucleus. So the sun is all ions, which means it is all plasma. The sun is just a bunch of plasma. So the sun first undergoes a proton plus a proton fusion. Now this doesn't make sense because that's a profoundly unstable nucleus. They would immediately repel. So proton-proton fusion can't. So even under that much pressure, remember how much I said that this column barrier, even on one individual proton, it would be 50 pounds of repulsion?
Yeah.
So that, even in the sun can't even beat that. The sun can't beat the column barrier of pressure. Because even 150 kilos per decimeter cubed, a decimeter is still thousands of times bigger than an individual proton. So the sun doesn't have even 50 pounds of pressure per one individual proton size. So it can't overcome this column barrier to fuse them. So how does it do it? Well, this is another thing. Don't ask me, but if ask someone smarter. But if you did ask me, it's because of quantum tunneling. So, because of quantum mechanics, we know that individual. Stupid ass garage door. Because of.
Just give it a second.
Because of quantum mechanics. Let me just tell what happened. Our garage door is possessed. It opens and closes on its own, and it just opened. So, because of quantum mechanics, things are not... particles are in a constant state of all states at once. It doesn't make any sense, but it's just how the world works. And that also means that all the protons within the sun have a non-zero chance of being even in this room right now. Okay? Non-zero. Now, it's called a probability amplitude because it's a wave, and a wave carries energy or an amplitude, and this wave has a probability of being throughout anywhere in the entire universe. But as it gets further away from its highest energy spot, which is what we would call the proton, as it gets further away from that, it has a lesser and lesser and lesser likelihood of being over there. So there is a possibility of two protons quantum tunneling or having a probability amplitude that is close enough for the strong nuclear force to take over, to just straight up sidestep the Coulomb barrier. Now, this probability amplitude has to get this positional probability amplitude has to get stacked on top of the fact that these are both protons, and that ain't going to work. One of them has to be a neutron. So the proton has to undergo a beta plus decay,
Right.
where the up down quark, one of the up quarks spontaneously, because of the weak nuclear force, I don't understand it, don't ask, because of the weak nuclear force turning one of these up quarks into a down quark, turning it into a neutron, which emits a positron and a neutrino. Mm-hmm. This we know happens because every square centimeter, all around us right now, every square centimeter, there's about 10 billion neutrinos flying through us. And those bad boys are coming from the sun because of this beta plus decay from a proton turning into a neutron, emitting one of these neutrinos. And all those suckers are coming down through us. So, those two things have to happen simultaneously. The proton has to quantum tunnel into the strong nuclear force distance of another proton, as well as this up quark has to spontaneously, because of the weak nuclear force, turn into a down quark, turning this proton into a neutron. Then you've got a proton-neutron nucleus. They have fused, which will release a profound amount of nuclear energy because of the binding energy. It's less in its final state than it was individually, which creates a nuclear reaction, which powers our sun. That's only step one. That's step one. You are confused.
Well, so the things have to take place. What am I getting at here? How do you control for this happening if things have to happen in a certain sequence? You see what I'm getting at here? So with the quantum tunneling and the flipping of the quark, right? Mm-hmm. If this is the mechanism we use for nuclear fusion, how do we control this in an environment?
Well, this is the mechanism the sun uses, and we can't do this.
Okay, we're still on the sun.
This
aspect.
is still just the sun.
Okay, so this is not practical yet.
Yeah, this is not practical yet. Like I said, the sun's fusion is profoundly different from our fusion.
Okay, what I was confused was like, okay, this is all just probability stuff that's out of our control.
This is probability.
Okay.
And speaking of that probability, at 15 million degrees, at 150,000 kilograms per meter squared of pressure, the chances, so that's a lot of protons just flying all over the damn place.
Yeah.
That's a lot of them. The chances of two of these neutrons smashing into each other and the probability amplitudes lining up so that they quantum tunnel while a beta decay happens is about 10 to the negative 28 per proton collision. 10 to the negative 28 probability of that happening. That is about 0.00023 more zeros 1% chance happening.
Yeah.
That is, if there were just two protons smashing together, that would not happen for billions of years. That would not happen pretty much at all. We would never see that happen in anyone's lifetime or a billion people's lifetimes. The chances of that happening are so low. But because the sun has so many protons in its core, this happens quintillions amounts of times every second.
Yeah.
Because there's just that many protons in the sun's core. So this infinitesimally small probability chance thing happens so much, just an incomprehensible amount to create an entire sun.
Yeah.
We don't have control over that probability on Earth. So, but the sun's not done. The sun's not done. So that's just how you get a proton-neutron combination.
Right.
Okay. That proton-neutron combination is just hydrogen 2. Hydrogen 2. Mm-hmm. So once you have this proton-neutron combination, this hydrogen 2 now easily can just grab another proton. Says there's so many protons flying in that sucker, that will happen in minutes or less. So that makes it helium 3. It's helium now. 2 protons and a neutron. Mm-hmm. So we just got hydrogen fused into helium. But it's still not done. The helium 3 fuses with another helium 3. So 2 proton-proton neutron pairs fuse. Now you have 4 protons and 2 neutrons, which is extremely unstable, which decays in the proton neutron nucleus is beryllium 6. It becomes beryllium 6 that the helium does. That's extremely unstable. It decays in a matter of picoseconds, less than 1 picosecond, in fact, just an incomprehensible on human scales amount of time, which becomes lithium 5. It shoots out a proton, becomes lithium 5, which is still unstable, shoots out another proton, which becomes helium 4, which is stable. That is how our sun fuses hydrogen into helium, with only protons. We can't do that. Specifically, the proton-proton fuse, we can't do that. Not even close. Not only do we not have enough pressure to get these things to quantum tunnel, and even with the sun's pressure, the chance of it quantum tunneling is still profoundly low. And we have no control over when a beta plus decay would happen. Just it's all probability in the sun. Yeah. It's all probability. It's all quantum mechanics in the sun. We can't rely on probability for power generation. So let's talk about how we fuse these suckers on Earth.